Now, a key aspect of your improvement efforts is being able to take data and analyze it and be able to understand the variation that lives in your data. But you really have two choices. Many people have been acquainted with static displays of data. What we want to talk about is the difference between static and dynamic. If you've had any course in basic statistics, you know that there are measures of central tendency, the mean, the median, and the mode. And there are measures of dispersion, characterized by the min, the max, the range, which is the difference between the min and the max, the absolute difference, and finally, the standard deviation. The thing is that these are all statistics trying to capture some static aspect of a distribution of data. The problem is that oftentimes summary statistics that are static in nature don't give you the appropriate picture of the variation that lives in your data. For example, let's say that you had two time periods, time 1 and time 2, and you had an average of something at time 1 and time 2. Doesn't really matter at this point. What do you conclude if I showed you in a meeting these two dots? You'd conclude that basically time 1 was the same as time 2. But then if I plotted data over time and showed you this is year 1 and this is year 2, and I plotted the 12 months of each year, and you saw that year 1 actually looked like this and year 2 actually looked like this, you'd get a very different picture. Obviously, movement downward, movement upward, yet the means are the same. This happens every time you have static displays of data. You have to ask yourself, does the statistic, mean, median, mode, standard deviation, really reflect the variation that lives in the data? Here's another example. Let's say that you have an average mean of something. Let's say that it's 76. How could you get that average of 76? Well, you could have data that look like this. You could have data that look like this. You could have data that look like this, and you'd get an average of 76, like this, or data that just randomly array themselves. Which one do you want? If you were looking at patient satisfaction, you might say, ooh, I like this one. It's going up. If you were looking at reducing infections, you'd say, ooh, give me this one. If you were trying to show that your intervention worked and you were here and then an intervention was here, you'd say, ooh, I like this one because we had infections up here, we made our change, and they went here. But the point is, they all produce exactly the same average. I have data sets that demonstrate that all 4 of these different arrays, or 5, depending on how many you draw, the max, the min, the standard deviation could all be the same. And yet they display very, very different patterns of data. Let me show you one final example, because if you've been in healthcare for any length of time, you've probably seen this happen. Thanks for coming to the quality meeting today. I have great news. Here is time 1 bar graph and time 2 bar graph. Average of 70 minutes wait time, average of 35 minutes wait time, and here, ladies and gentlemen, is where we made our intervention. Look at the big difference between time 1 and time 2. Now the question becomes, how did the 3 units that were part of this initiative fare from time 1 to time 2? And you say, oh, well, I can show you. Here is unit 1, here is unit 2, here is unit 3. Now, each one has time 1 measure, time 2. Here is where the intervention occurred, between time 1 and time 2. Here is the data for unit 1. It was here, and then it was here. So here's the average of 70, average of 35. Unit 2's data looked like this, average of 70, average of 35. And finally, unit 3, its data looked like this, it went like this, but now it has gone like this. Average of 70, here, average of 35. Only one of these units actually can be characterized by these 2 little bar graphs in relationship to the intervention here. Which one is it? Unit 1, 2, or 3. I oftentimes get people saying Unit 2 because they see what some would call, a downward trend. I could put a regression line on that and call that a downward trend. Well, in fact, it is getting lower, but the question is, did the intervention that we did right here have an effect on the process and its variation? The answer is no. It was getting better, and it continued getting better, but there was no response to the intervention. This unit was up here. It did go downward, but now what's it doing? It's heading in the wrong direction. Unit 1 was here. It shifted and went here after the intervention. It is Unit 1 that is the only unit that actually can be characterized by static displays of data. It's not until you lay data out over time that you actually are able to understand the true variation in data. So we'd ask you to think about, what are the choices you're making when you look at data? Do you look at data from a static view or from a dynamic view? Hopefully, your quality improvement efforts will be using more of a dynamic display of data that plots it over time.